Alright guys, my last video for you for this school year. I know you're just as sad as I am to be listening to it. So, we are on number 11. I haven't looked these over, so hopefully we're able to do them all. So, I'm kidding, we're going to be fine. The position of a particle at any time t is greater than or equal to 0 is given by blah and blah. Find the magnitude of the velocity vector at the time t equals 5. Alright, so to find the magnitude, you had a formula. Your formula was the square root of the derivative of dx dt squared plus dy dt squared. So, I guess we should have x of t up here. It's t squared minus 3. And then we should have y of t is equal to 2/3 t cubed. And let me go ahead and turn on the light, because without the light it's getting a little weird. There then. Although you can see the reflection of my light fixture up there, I think the light's going to help us out a bit. It's the first time I've done a video at, it's like 4 something. 4:21. Super late. So anyway, the derivative of t squared minus 3 is 2t. So we got 2t squared. Plus the derivative of 2/3 t cubed is going to be 2t squared. So you've got the square root of 2t squared plus 2t squared squared, and you want to evaluate this at t is equal to 5. So we get the square root of, that's 10 squared, or 100, plus 5 squared is 25, 25 times 2 is 50. So that's going to give you the square root of 2600, which you can reduce to 10, the square root of 26. Probably 26 can be reduced more, so it's probably not even, no it can't, because it's 2 and 13. So no, 10 to the square root of 26 is as simple as it will go. If I were telling you on an AP exam, you would want to stop at the square root of 2600, but if it was multiple choice, they would go to 10 square root of 26. But as long as we understand how to do the problem, we're good to go. All right, part B says find the total distance traveled by the particle from 0 to 5. All right, so when you're doing that, the distance is just going to be the integration of the magnitude. So 2t squared plus 2t squared squared dt. Now, I put that in my calculator. Now, on my paper, I've got it done without the calculator. But you know what? Our AP exam is done, and I know you guys are really done. So we're just going to go with it. We're going to put it in our calculator, and so our answer is 87.716. Again, you'd want to square those. You get 4t squared plus 4t to the 4th, and you want to integrate them. It's a whole big deal. Much easier to do in your calculator. All right, part C. Part C, find dy dx as a function of x. All right, so dy dx is going to be dy dt, which we know to be 2t squared, over dx dt, which we know to be 2t. So the 2's cancel, the t's cancel, you're just left with t, right? But they wanted it in terms or as a function of x. Okay, well, that's a t, not an x. So we come up here and we've got, well, x is equal to t squared minus 3. So in order to solve for t, I would need to add my 3 and take the square root. And I find out that t is the square root of x plus 3. Now, how do I know that it is positive and not negative? Well, over here, we said t is greater than or equal to 0. So if t is greater than or equal to 0, then t's got to be positive. So your dy dx is equal to the square root of x plus 3. Done. All right, moving on to number 12. Number 12 says, point P moves in the xy plane such that dx dt is equal to this and dy dt is equal to that for t is greater than or equal to 0. Find the coordinates of P in terms of t, given that when t is equal to 1, x is equal to ln 2 and y is equal to 0. So, what does that mean? That means that x of 1 is equal to ln 2. Y of 1 is equal to 0. Now, if they told us that dx dt was equal to 1 over t plus 1, the dog scared me. We're getting a package delivered. Dy dt is equal to 2t. All right, so to get back to the function, what you have to do is you have to integrate, okay? So we want to integrate 1 over t plus 1 dt. Now, that could be your u. Well, if u is t plus 1, the derivative of that is just 1. This is basically 1 over u. And the integration of 1 over u is ln of u. So x of t is equal to ln of u plus c. Now, use your differential equations. So you know that if x of 1 is equal to ln of 2, when x is equal to 1. So basically, if ln of 2 is equal to ln of 2 plus c. All right, well, if you subtract ln 2 from ln 2, you find out that c is equal to just 0. So your x of t is just ln of t plus 1. All right, moving on to the next one. We want to integrate 2t dt. So y of t is equal to 2t squared over 2. So that's just t squared plus 2. So y of t is equal to 0 when t is equal to 1. So you get, in this case, c is equal to negative 1. So your y of t is equal to t squared minus 1. Okay? So your x coordinate is ln of t plus 1. Your y coordinate is t squared minus 1. All right. Part B. Part B says, write the equation of the expression. Write an equation expressing y in terms of x. Expressing y in terms of x. All right, so part B. So x of t is equal to ln of t plus 1. And y of t is equal to t squared minus 1. So what we want to do is we want to replace that t squared with terms of x. So we need this thing to basically equal just t. So what I'm going to do is I'm going to make this just x. X equals ln of t plus 1. And actually, like, it's kind of hard to see in this. I'm going to switch them around. I'm going to have the ln of t plus 1 is equal to x, because then I can change this over to look like this. Log base e of t plus 1 equals x. And now I can do my log loop. Now, we could have gone the other way, but, you know, moving things backwards is sometimes hard. So e to the x equals t plus 1. Which means t is just going to be e to the x minus 1. Now that I know what t is in terms of x, I can say that my y of t is equal to e to the x minus 1 quantity squared minus 1. So I just substituted that t in with what my x equation was. All right? Well, that was my B portion. All right, let's look at part C. Part C says, find the average rate of change of y with respect to x as t varies from 0 to 4. All right, what is the average rate of change? the average rate of change is just going to be slope from 0 to 4. So we're just going to find the slope from 0 to 4. Slope. So we've got y of 4 minus y of 0 all over x of 4 minus x of 0. Now, we remembered the x of t was ln of t plus 1, and y of t was equal to t squared minus 1. So when you plug in a 4 into the y, you get 16 minus 1 is 15. When you plug in a 0, 0 minus 1 is a negative 1. And then our denominator, x of 4, that's going to be ln of 5. Minus, when you plug in a 0, that's going to be ln of 1, which we know is just 0. So we end up with 16 over the ln of 5, because this just equals 0. Okay. All right, part D. Part D says find the instantaneous rate of change of y with respect to x when t is equal to 1. Well, instantaneous rate of change, that's the derivative. It's almost like we're going back to early days, like chapter 2, except this time we're dealing with vectors and parametrics instead of, just a regular thing. So instantaneous rate of change, we're just looking for the derivative. So dy dx. And then we want to evaluate that at t equals 1. So dy dx is equal to, so the derivative of y, well, they gave it to us, didn't they? Yes, they did. They gave us 2t divided by 1 over t plus 1. Now, I'm just going to evaluate this for t equals 1. I mean, you could keep change flip at this point, but why not put the numbers in and then keep change flip? So if you plug in a 1, that's 2 over 1/2. Keep change flip, your answer will be 4. Okay, so your derivative evaluated at t equals 1 is just 4. All right, our last problem, number 13. Number 13 says, consider the curve C given by the parametric equations x equals blah, 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 and y equals blah, 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 for negative pi over 2 to pi over 2. So that's the right half of the circle. Find dy dx as a function of t. All right, so we have that x is equal to 2 minus 3 cosine t, and y is equal to 3 plus 2 sine t. So dy dx. dy. Well, the derivative of 3 is 0, derivative of sine is cosine, so we have 2 cosine t. For dx dt, we've got the derivative of 2 is 0, the derivative of cosine is a negative sine, so a negative sine is a positive 3 sine t. Okay, now you could reduce this to 2/3 cotan t if you wish. If you were doing multiple choice, they would go ahead and make it cotan t. If, for whatever reason, you were doing a free response, I know, we're done with the AP, you would leave it. You could leave it. 2/3 cosine over sine. All right, part B. Part B says, find the equation of the tangent line at the point where t equals pi over 4. All right, equation of a tangent line. We need a point and we need a slope. So the point, we've got pi over 4. Oh no, wait, they said t is equal to pi over 4. So, t equals pi over 4. We got to find the x and we got to find the y. So x is going to equal 2 minus 3 cosine of pi over 4. Well, the cosine of pi over 4 is square root of 2 over 2. Okay, so that's ugly. We have 2 minus 3 square root of 2 over 2. The y is going to be 3 plus 2 sine pi over 4. Well, sine pi over 4 is square root of 2 over 2. So that one's a little prettier. It's just 3 plus the square root of 2. That's our point. Now we need to find our slope. Well, the slope is found by the derivative. Your derivative is 2 cotangent t. 2/3. Can't speak. I can feel the end. I'm just getting excited. 2/3 cotan of pi over 4. Well, cotangent of pi over 4 is just going to equal 1, because tangent of pi over 4 is 1. You flip it over, it's still equal to 1. So your slope is just going to be 2/3, because this is just equal to 1. So here's your equation. Y minus the parentheses of 3 plus the square root of 2. You could distribute that parentheses if you wish. We're not going to. We're just going to leave it like that. Equals 2/3 times x minus the parentheses of this ugly thing. And you've got your equation of your tangent line. All right, our last one. Part C. All right, the curve C intersects the y-axis twice. Approximate the length of the curve between the two y-intercepts. All right, so here's the deal. And also, remember those directions. Use your calculator on problems 10 and 13C only. So we know that we're going to do the integration of, oops, you can barely see that, the square root of dx dt, so that's 3 sine t squared, plus dy dt, because that's 2 cosine t squared dt. We just need to know what those intervals are. And it says that it intersects the y-axis twice. All right, so if it's intersecting the y-axis, that means that x equals 0. Okay, so x has to equal 0 in order for it to cross the y-axis. So our x equation was 2 minus 3 cosine t, and we want it to equal 0. So you can subtract the 2, you can divide by -3, and cosine t, when cosine t equals 2/3, well, the problem is, I don't know when cosine equals 2/3 because it's not on my unit circle. Well, you might recall from trig, in order to get the angle measure, you've got to use second cosine. So what we would do is we'd say second cosine of 2/3 is equal to 0.841, but we'll just say 0.84. So cosine when t is equal to 0.841. Now, think about this logically. If you have a unit circle, whatever cosine was equal to here, like let's say it was at pi over 6, it was also equal to that here. We just called it negative pi over 6. This is positive pi over 2. This is negative pi over 2. So if this were positive pi over 6, this would be negative pi over 6. Which means that if this one is positive 0.841, this one would be negative 0.841. Okay? They're going to equal the same thing, and it's not pi over 6. I was just using that as an example. So because of the way the unit circle works, and we know that cosine is positive in quadrant 1 and in quadrant 4, and they told us that we were using the interval from negative pi over 2 to pi over 2, we know that the bottom part is negative 0.841, and the top part is a positive 0.841. And that's all we needed our calculator for right there. Okay? So then, well, okay, I'm just kidding. We got to put this in our calculator. But I already did that, so I'm not going to type it in for you. It is equal to 3.756. You could certainly type it in your calculator if you wish. You're going to be so sad. You don't get to hear my voice every day. But you made it. You did all of this calculus. And now you are finally done. Finish up your portfolio. Finish up all your stuff. Let me know if you have any questions. If you are an underclassman, we don't know about your calculator yet, you hold on to that for us. If you are a senior, please make sure if you borrowed a calculator from us, you return it so that I don't have to hunt you down and find you. I hope you guys have a wonderful summer. If you are an underclassman, make sure you come and say hi to me next year. And if you are a senior, hopefully you get to go wherever it is that you want to go. But do come back and visit when you get a break. All right, I will talk to you guys all later.